Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're working on getting the bat AI, right? I'm calling it bat pathing or whatever. So we've got this kind of like wiggle where he'll kind of approach us in a zigzag and then he'll stop once he gets a certain amount close to us. Now the issue here is if we go into, I want to say it's here in the bat walk state, we can print up the distance we are to the player. And the distance we are to the player is a result of a function we wrote that calculates it. So if we look at what the distance to the player is in the fly state here, you'll see that once it hits 30, is it, or 25? I guess 28. So once we're 28 pixels away from the player, it stops moving. Now, the issue is if we're above it, like let's look at how far the bat is from us, right? It's like 16 pixels or so, like a whole tile size away. But if we're at the bottom right of the bat, look how close he gets. He gets like within 3 pixels of touching us. And that's because we're calculating the distance between the player. Yo, Brett does Twitch. Hey, thank you for the sub, dude. Appreciate it. Welcome in. Yo, oh, you know what that means? You know what that means? Thank you for the sub. We get to add you to the credited supporters in the credits of the game here. So we can add you right here. Where is it? If I could find it. If I could find it. Here we go. We'll put you right here at the end of the credits. Cool. You are in the credits now. Yeah. Epic honor. Thanks for the sub, dude. Appreciate it. Yeah, we're working on the bat entity for the demo, right? So in the dungeon, we have a bat, and he's tracking us. It's just that the distance is all jacked up. So like we have him stop pursuing us once he hits 28 pixels away, which if he's on the right side of us, that looks to be like almost a whole tile size of 16 pixels away. But if we're at the bottom right of him, look how close he gets. He gets like within like 3 pixels away from us. And that's because we're calculating the distance between the top left of our player and the top left of our bat. So since our bat is so long, 28 pixels away, that's the distance that we're normally making him stop at. But since he's so long, he gets really close to us. Because if we're on the other side of him, well, I guess the other side of him's the same issue. Because it's a little better because we go from the top left of him to the top left of us, and we aren't that wide. So basically, we just need to make this distance to player more accurate so that we get about 16 pixels away from the player no matter what side he is from us. So we're gonna tweak that distance to player function so that it modifies the distance to player on the bat to be more accurate. So we kind of want this function to give us the distance from, if we're on the left side of it, it's like we want the distance in between, right? Like the distance in between our player and our bat, which in this case is the right side of our player and the left side of our bat. But on here, if we're on this side, it's the distance between the right side of our bat and the left side of our player. So we need to orchestrate a different function to give us a better value there. And I think we're going to do it. This is it right here. And we literally do the Pythagorean theorem here, where we calculate the length of the A side of the triangle, the B side of the triangle, and that is like the hypotenuse is the length between the X and Y position of our player compared to our bat. So like, I think we need to calculate different lengths based on the orientation of our player to, like, you know, if we're on the left side of it, it's going to be a different formula than if we're on the right side. Origin is in the top left. Yeah, so everything in Lua, 0, 0 is going to be, or everything in Love2d, 0, 0 is the very top left. So X going positive goes to the right, and then Y going positive actually goes down. So that's how it is in Love2d. So it's a little different, but we need to calculate different A length and B length based on the, what do you call it, orientation of the player to the entity. So I think we can get away with just doing basic quadrants. So like, I'm trying to think if we want to go, yeah, I think we define it in terms of which quadrant, right? So like if we're up left of the bat, then we calculate a certain way. Gosh, it's hard to imagine this, but it definitely isn't this, where it's always calculating based on the top left of our character. So I guess the first step would be to figure out which quadrant our bat is in compared to the player. And then figure out how to calculate the correct lengths to our triangle. Because if we, maybe it's easier if I draw it up. Let's see here. Hey, Ghoulable, yes, the bat is an enemy. And what's up, Sasquatch? How's it going? Yeah, so in the game here, we don't really kill any of the creatures, but they're corrupted with that purple. So the goal is like, we just hit them with the spell cast to kind of cleanse them of their corruption in a way. Okay, here we go. So yeah, so the you know, like if this is our bat and this is our player, then what I'm calling the A length is the difference in X. So the A length is we get the difference in X right there, that's A. Then we get the difference in Y, and that's B. And then we do A squared plus B squared equals C squared for the C distance. So if our bat, since our bat is longer than it is than our player is, we don't want, like if we imagine what, you know, like the bat is actually dotted like this and he's wide. So the bat's wide. We want the distance between this point and P right here. So like this part will become our C instead of the top left and top left. So and this point calculation differs which quadrant the bat is in compared to us. So if the bat's in the top left quadrant, we want the C calculation to be the bottom right of our bat. If it's in the bottom left quadrant, then we want the top right of our bat, right? So if this is our bat here, then the point right here to our player, that would be the C length for here. And then if the bat's over here, we want the top left of the bat, and that'll be the distance. So from right here. So that in this case, the current method is right, because we're going from the top left Well, I guess it's even more complicated than that, because here, since the player's top left, the player also comes out to be like this. So we want to calculate the player from this angle to the bats this angle. So this will be our C. And then this is the difference I'm talking about, like calculating the distance in between these 2 points. That'll be more accurate, you know. And then let's just kind of map out what this one would look like. So if the bat is like this, then we want the bottom left of our bat to the top right of our player, right? And that'll be C. So depending on which quadrant our bat is in, we have slightly different logic to calculate the length of the triangles and then calculate the Pythagorean angle of that hypotenuse. And then, I might need to keep that up as reference, but the first step is to figure out which quadrant logic we need to apply to it. So I guess we just have to ask, we compare the X and Y, and if our bat's X is smaller, then we know the bat's on the left side. Then we can ask our Y, and if it's smaller, then we know it's at the top left. So let's do that, where we can say, since we define this function in terms of the bat, because it's on the bat walk state, and maybe this should actually be in the entity class, because this is something we would want for multiple entities, right? Probably. But let's just see if we can get it to work. It'll be easy to shift it into the entity class once it works. So we're going to ask in relation to our bat. So if our entity's X is smaller than the player's X, then we know the bat is on the left. But then we need to ask, if the bat's on the left, then we ask about our Y. And if our Y is smaller than the player's Y, then we know the bat is in the top left quadrant. In relation to the player, right? So it's top left of our player. So this is where we can put top left logic, and we can do an else here, which will catch the bat on the right. Bat is on the right. And then we can say, once we know the bat's on the right, if our bat Y is smaller than the player Y, then we know it's in the top right. And then all we have to do is add the else to catch the last one of this is bat in the top left, then this would be bat is in bottom left. And that's because our bat is smaller than our X is smaller than the player's X, so we're on the left, but our entity Y would be greater than the player Y, meaning, we're in the bottom. Cool. And then this one would be top right, and then this would be bottom right. Bat is in bottom right. Okay. So here's the breakdown. So we have all the spots to do the logic we just kind of drew out, but now we have to kind of let's refer to it. I'm gonna leave this up on screen here, as crappy as that looks, so we can kind of see it. So if the bat is in the top left, we want to calculate the distance between the bottom right of our bat and the top left of our player. So bottom right of bat to top left of player. And then if the bat's in the bottom left, we need to do the top right of the bat to the, I guess it would be the bottom left of the player. We drew this a little wrong, but it would be the bottom left of the player. I guess it kind of matters. It kind of depends, because in this scenario, if the bat is, for example, perfectly to the left of the player, like same Y, but just different X, we need a, I guess, because we're not catching what happens if the player's Y, oh yes we are, if the player's Y is exactly equal to the entity's Y, then we're considering it to be the bat is in the bottom left quadrant. So I guess it makes sense. In my brain, I think it makes sense to let me think. Because yeah, if we're same Y but just the left of us, how should we calculate the distance to the player? It's just going to be the right side of us compared to the left side of our player, if that's the case. If it's equal. So, okay. I think we might have one more condition in both of these because of the bat's logic. It tracks. It basically only moves perfectly diagonally or perfectly orthogonally, with the exception of we wiggle a little bit on the displace, like we wave a little bit. So you know what? Yeah, let's leave out that third condition and let's just say that this is smaller than or equal to, and this is greater than or equal to. And then we want to do the top right of the bat with the bottom left of the player here. And then if the bat is on the top right, we want the bottom left of the bat to the top right of the player. So bottom left of bat to top right of player. And then if we're in the bottom right, top left to top left of bat. To the bottom right of player. Okay. So now that we've got that kind of planned out, now we can just fill in the actual code. So we basically need to calculate this A length and B length for each of these scenarios. So in this case, we want the bottom right of our bat. So that would be the entity. Let's do this. So A length is what we're calling the X, the horizontal leg of our triangle. So if the bottom right of our bat, that's going to be our entity's bottom right. Let me think this through. Bottom right of our bat, the X of the bottom right would just be the entity X plus the entity width. Because that's the right. And then we basically want to get the difference of, so I think we need this in parentheses. So we get the right side of our bat first, then we subtract the difference between the top left of our player, so that's just player X. Okay. That looks right to me. Now the bottom right of our bat, so the bottom right of our bat would mean that the Y would have to be plus the entity's height. And then, I guess, to the top left of players, we would do the minus player.y. Okay. So if the bat is in the top left of us, then we're calculating the A length and B length based on the bottom right of our bat to the top left of our player. So if we just have this where the bottom is top right, yeah, I think this might work. Okay, so let's do this where if the bat is in the bottom left of us, then we want to calculate based on the top right of our bat. So top right would be, X would be the right side of our bat. And then to the bottom left of our player. So since it's the left of our player, we can keep player X. That tracks. Then the top would be just entity Y. And then to the bottom left of our player, so that would be a player Y plus the player height. Okay. And then we have bottom left of bat, so it would be just X compared to top right of the player, so we can do player X plus player width. Okay, and then bottom left of bat, so the bottom would be entity Y plus entity height. And then to the top right of the player, so it would be, top would be just player Y. Okay. Okay, and last one. Top left of bat. So since it's the left, it's just entity to the bottom right of the player. So since it's the right, it would be X plus width of the player. That looks right. Then top left, so it would be just entity Y, because it's the top of our bat. And then to the bottom right of the player, so it would be player Y plus height. Okay. So, and then we go ahead and get our A squared and B squared, C squared, and then we square root our C squared to get the length, which is our distance to player. Okay, so let's see. What are the chances this is okay? What are the chances it doesn't crash? Okay. It's still at 28, I believe. Distance to player 28. So look how far away that is. It looks like almost like 32 pixels. It almost looks like... Okay. As long as it's consistent. That looks pretty consistent. So if we're... Oh. Yeah, let's really knock down the distance, because the distance is way too much now. So let's do this here's the distance. So let's half this. Let's go 14 pixel difference. And we'll see. We're looking for a consistent looking distance. So we'll start off with it. We're in the top right. So let's see. Okay, we want it just to be in range of our spell casting. So 14 isn't close enough. So maybe something like 10 would get us right in the range here. Hey, what's up, Squinch? Hey, it's going good. I think we might have figured something out. So that looks pretty good. That looks about 16 pixels away. Let's try the bottom left quadrant. That looks pretty good. As long as we can barely touch from all quadrants. Oh, that's way too close. The bottom right is still messed up. Maybe not. He worked okay there. Oh, why did that get all screwed up? Wow, yeah, 10 pixels when we're just on... Oh my gosh. Okay, Squinch, so it's maybe not going so great. Because look at the distance here. 10 pixel distance gives us like 5 pixels of difference. But then over here, 10 pixel distance. Oh, look at that. Oh my god. 10 pixels is like nothing. Why did he keep going? Oh my god. Because depending what quadrant we're in, calculates different. Oh, see, that's way jacked up. So bat in the bottom right seems to be wrong. So when the bat's in the bottom right, we're going from the top left of our bat to the bottom right of our player. Yeah. Bottom right of our player, top left of bat. I don't know. It looks like we've got the logic right there. Oh, nice. What are you talking about? Like how close the bat can get before it stops moving, or what issue are you trying to recreate? This is way jacked up. This is not right at all. Yeah. Oh, that's so... That is not right, man. Yeah, you shouldn't be able to do that. Yeah, it's... This isn't quite right. I think... Let's take out the equal to. I don't think that'll really matter that much. I think I know what the issue is, but I don't know how to fix it. So it's like here, since the bat's kind of like going up and down, it's calculating the distance between the bottom left of the bat and the top right of our player, which if we draw a line there, it's actually like, it's going the opposite direction, because like this calculation's based on it going down, connecting to the top right of our player when he's above it. So maybe we have like a grace period, because like if we're basically in the same 16 pixel Y of our player, we just want the distance to be the right side of our player to the left side of our bat. That's it. It's only if we're literally in the diagonals that we want to calculate it based on these special positions. So I think we need eight cases, right? We need to catch it in the diagonals, but also catch it on the orthogonals. so that we're giving more accurate distance to player based on which angle it's approaching at. So it's, I guess now we have to kind of figure out, how do we decide if something is, just because the origin positions are technically in the top right, does it consider itself just right? Okay. I don't know how we do this. So I guess what we could do, if we forget about this for now, if we forget about the diagonals for now, and just kind of do the logic, if we're within 10 or 16 pixels of the same X or Y position, then we do the appropriate orthogonal movement. And if it's not in that range, so let's do this, where we say, like, we're just gonna do the difference between our X positions. And if the absolute value of our X positions is, let's do 10 pixels, I think. If the absolute value of our X positions is 10 or smaller, so if our, I think we're running into a circular ray cast around the bat that would let you see if it contacts the player. I'm not looking for just collision. We've already got like the collision for it. It's just that I want like a consistent distance between our player and our bat, so that he's always just in range of our spellcast on any side. So like it's just weird, because depending on what side we're at, we have to kind of calculate the distance. Because our bat isn't a square, it's way longer than a square. So that is what's creating this issue, I think. Okay, so I think if we do this and we say if our bat is within 10 pixels of our player's X position, then we want to just do, well, then we have to check. If we're within 10, then let's ask if the entity is above us or below us. So is the Y smaller than our player position? And if so, then we can do the, if our bat is above us, then we need to calculate the A length and B length based on the bottom of our bat and the top of our player. So the bottom of our, oh my gosh. Yeah, it'd be bottom of bat to top of player. Okay, so it's almost like we don't need to do the Pythagorean theorem here. We know the distance, and the distance is just the distance between the bottom of our bat to the top of our player. So instead of calculating the lengths there for A and B length, we can literally just modify the entity's distance to player at this point, and distance to player. Is that right? Okay, so the distance to player would be this bottom of bat to the top of the player, so it would be the absolute value. Well, I guess we don't need to do absolute value because we know the bat's above us. So it would be the bottom of the bat. I guess it would be top of the player minus the bottom of the bat. So player y minus the top of the bat, and that's the distance to player. So I guess what we can do here we assign the distance to player here, and we could change this to say, because we don't want to overwrite this C length if we're in one of these orthogonal cases. So what I'm going to do is just say that if our distance to player is not equal to 0, or how do we do this? We want to do this only if it's an orthogonal case. So we can say if it is, let's do this, where we can say if it's equal to 0, that's when we're going to inherit this, and we just have to say we're going to flush our distance to player to 0 at the start of this. So if we hit one of these orthogonal cases, the distance to player will no longer be 0, it'll be whatever the distance to player is. So like, let's say 12 or whatever. Then when it gets to here, if the distance to player is 12, it is not equal to 0, therefore we won't overwrite with our C length for the diagonal case. So let's just see, let's turn this back on for our diagonals, but then let's try to, we'll be within 10. Oh wait, hold on, this is, if our X position is within 10, then the player, okay, so let's try to get the bat to be above us. Let's get the bat above us, and then we'll see if we have a decent, I don't know. Let's see, because we're looking for a distance of 12 or whatever. So it stops. Oh god. Okay, so if the bat's above us, it should stop at like 12 or whatever. Oh, 10. Okay. That's looking okay. So let's try to get the bottom case for it. Because see, it's see, that's still broken. So this would mean the bat's beneath us. So we're going to go from the top of bat to bottom of player. So we're going to assign this distance to player to be top of bat to bottom of player. So we want, what do? We take the bat's Y position. Yo, Sasquatch, hey, thank you, dude. Hey, I really appreciate that sub, dude. Thanks for the prime sub. That's epic. And you are already in the credits. I know that for a fact. So I know your name's already in there. But thanks, dude. I really appreciate that. Top of bat to bottom of players, because we need the distance, so we need to do the bat's Y, entity Y subtract bottom of player. So bat's Y, subtract bottom of player, which would be the Y plus the height. Thanks, dude. I really appreciate that. That's epic, man. Thank you, thank you. That is so cool. And for anyone who doesn't know, the revenue from the Prime subs and subs in general are going towards paying to get the game listed on Steam, and we've already surpassed the $100 that we need to get it hosted there. So we're already golden on that. So thank you all for the support. That's huge. So like we can get the game up on Steam thanks to the community here. And this is looking good. That 10 pixels looks pretty consistent. That's looking good. So let's get the left and right figured, because look how bad that is. That is not right. It says it's 10 pixels, but what's really happening here is it thinks the bat is in the top right quadrant, so it's drawing a line from here to there, and that's why it's closer than it should be. It should be stretched out. It should be further away here. So that is really close. And then once we get this working, then we get to work on the bat's attack state so that it can spit and damage us. Because I don't want every entity to just walk towards us and damage based on collision. If you walk into them, it'll damage you, but the bat itself is going to be doing projectiles. So that's the goal. So here we have... Okay, so we want to do... If our x is within the same... Okay, so then we need to do... If the absolute value of the difference in y positions, so if we're about the same up and down as our player within 10 pixels or so. And the 10 pixels there comes from, I think, the displacement x. That's what I call like the waviness, because the bat doesn't just go straight left to you or whatever. It kind of like waves. So the 10 is supposed to catch any distance in that wave so that it doesn't throw off that diagonal distance calculation. So that's what we're trying to catch here. So if we're about the same y as our bat, then we need to see, okay, are we on the left side or on the right side? And then calculate the distance to player, not based on the Pythagorean, but just on the sides. So if our bat is to the left side of our player, then the distance would be the right of bat to left of player. So that would look like the entity's x plus the entity's width. That's the right of our bat. And what we're doing is we're assigning the distance to player based on this. So distance to player gets the right side of the bat, let's see, to the left of the player. So we want to do the player's left subtracted by the right side of our bat so that we get the distance in between them. The left side of our player, subtract the width. Hold on, this right of bat to left of player. We need this in parentheses. So the bat's on the left of us. We're taking the right side of our bat. Gosh, it's hard to think about. If our player's to the left of us, take the player. Yeah, and then we subtract the right side of the bat. Yeah, I think that's right. Then if the bat is on the right side of us, we need to calculate it based on the left of the bat to the right of the player. So that would look like left of bat to the right of player. So we need to say we would take the left of bat and subtract by the right of the player. So entities distance to player is going to be the left of the bat, so just the entity's x, and then we're going to subtract the right of the player. Player x plus player width. I think that's right, because that would be... I think that's right. Let's see. We're looking for a more consistent distance that the bat stops at when we're at the same Y position. So once it's doing this zigzag, 10 pixels, that looks a lot better. It looks almost like a whole tile size away, right? So if it's got a matching distance when we're on the right side, that looks about right. And then let's try the diagonals. If we're upright, yeah, we get almost like a whole tile size away. Top left looks a little far. We're still at range to hit it. Bottom left looks good. It looks like the top left and bottom right, well, I don't know. They just look a little too far. Because that looks, well, that still does hit. It does hit. Let's take off the values here off the debugging so that we can just see and make sure that our spells hit on any direction. So here's what the bottom right, that looks like we hit. Top right, we hit. Bat's top left, we hit. Bottom left, barely hit. And then the sides are much closer. They're like definite hits. Yeah, like that definitely collides. That definitely collides. Okay. Oh. Okay. Yeah. I think we're... I don't know. We're really close. I think it just needs... Like, that looks just too far away. So the bottom... When the bat is in the bottom right, we need it to be a bit closer. So if the bat is in the bottom right, where do we do this? So bat is in bottom right. How do we modify this to be a little bit closer? So we would need we want the hypotenuse to be calculated to be a smaller number. So that would mean we need our sides to be a smaller number. So let's just try... I just want to try to do a couple pixels worth here. Let me just see if this does anything. I don't like the magic number in there, but I'm just trying to see. Oh, and that was if the bat is in the bottom right. Okay. Just to see if that does, in fact, get us a bit closer. It does look closer. Okay. Now, also, when the bat is in the top left, it also needs to be a bit closer, I think. So, like, that looks good. Yeah, like that's like definitely colliding now. Then if the bat's in the top left, yeah, see, he needs to be closer, just a bit closer in the top left scenario. Bat is in top left here. If three is a decent distance to shrink those by, we'll turn it into a constant. That looks better. That looks better. Nice. Yeah, so bat bottom left could afford to be a bit closer, and bat bottom right or top right could be a bit closer. So I'm kind of thinking we switch this to 2, and then we just do a 2 pixel shrinkage on all of them. Okay, let's test it out. Okay, so we're going to see how close the bottom right bat gets to us. That looks good. Maybe, yeah, maybe 3 pixels is the way. That's okay. That's okay. Yeah, you know what? It feels like only the bottom right is a little too far away. Well, you know, I think it's okay. That looks pretty good. Cool. Now, we haven't tested multiple bats now that we've given them the what I call displacement value, which is just like the zigzagginess when he's orthogonally adjacent to us. So now that we've got this, let's give us this constant. What would we call this 2? We can call it I guess, I don't know what we can call it. Call it bat proximity shrink. I don't know. Bat shrinkage. Bat distance modifier. I don't know. I'm just going to call it bat distance. Okay, so now that we've got that kind of okay, I want to go and give us 2 or 1 more bat. Let's see. So we give ourselves another bat, and let's give us a 3rd bat. And we'll see. We did all of this stuff. Hey, what's up, Loki? Squinge, is that checking based on delta time? Checking what based on delta time? I'm not sure what you're asking. Okay, so we've got 3 bats. Let's see. We just... Okay. This is because when we instantiate our bats, we need to make sure to give it a walk speed and a displacement magnitude. So displacement magnitude, we can shift a little bit to give it more variety in its flying. For right now, maybe we just give one of them 4. I'm kind of curious if we give it different values, because the whole reason we did this is so that the bats don't overlap with one another and kind of lose themselves inside one another. So we want them to be doing like unique movements. Oh, that looks great. Oh my gosh, that guy got really close. Oh, see there. They all got stuck together there. Once they get like stuck inside each other, it's like really tough for them to decouple. It's looking pretty good though. Maybe the displacement magnitude was too short on that guy. I don't think there'll be where we have like 3 bats in one dungeon, but now that I'm thinking about it, maybe the move we do, maybe what we can do is have like a bat cave in the dungeon, and it's a bat spawner, and one will just fly out of there and bug you in every dungeon room. And then maybe part of the puzzle could be you push a crate in front of the bat spawner. Maybe we can do something like that. Gosh, see, that's what I was trying to fix, was the bats just getting stuck inside each other like that. I think it's okay, because I don't think we're gonna have 3 bats spawning at once. Yeah. I don't know. How else could we fix this? Like, we could... I guess what we can do is, like, if by the time we're at that threshold of distance to player 10 or less, then we can check. I don't know. There's too many things, because if we want to set some kind of drift for the bat so that they don't live inside one another, then when we scoot them, there's a big possibility that we scoot them out of range of our spell casting, because right now they're like just in range of our spell casting, and if we scoot them so they're not inside each other and it scoots out of our spell casting, then we can't cleanse them or attack them. So I think this is okay for now. Once we actually, whoa, that was kind of cool. I didn't want that to happen, but that was kind of cool. The bats kind of flew away when I opened this. What? Why did he do that? That is strange. Okay, we're updating our bat entities even when we're in a paused state, I guess. I think once we open a treasure chest, I think we become paused, which should stop entity updates from happening. But look at this. I like that they fly fast, but it's not supposed to happen. Let's find where we open this coin. Would it be in the treasure chest? How do we do this? Once we treasure chest open... Yeah, once we become... Let's do this. Let's find the open chest. And just make sure we do become paused true. So we need to only update our bats if we're not paused. So we could do this where we... Gotta be a better way of doing that. Because we don't want to update our bats if the game's paused. But I think the way to do this is just to not update our entities at all if we're not paused. And let's see if we're doing that in our entities. We could... Oh, see, look, we still have... Oh, here. In the state machine update, we can do this if not paused. And that'll be better than this solution. So let's do that. We still have gecko-specific logic in our entity class, which we should factor out. But here, in the entity state machine update, we only want to update the state machine if we're not paused. So now the bats should not fly off once we... Yeah. Squinch, I've got a Discord link right there for you. Let me know if it doesn't work. I know sometimes the links expire. Okay, so let's see. They're chasing us. We open this up. Ah, son of a bitch, they still fly away. It might be in the entity. Because it's like the state machine for the walk state isn't getting updated. But maybe the entity is. Let me see. Entity, where do we do an entity update? This is the entity class. Okay, so let's still update the state machine, but let's not update the entity itself. So is the entity in our scene class or our map class? What do we do? Entity update. Entity updates here in the map. Yeah, so we want to do this also and not paused. We don't want to update our entities if our game is paused. That goes for both, let's see. Do they fly away? They still fly away. What the heck? And we're doing this. Look, if we don't update the entity, they don't fly away. Okay, well, let me see that again. Let's wait till they hit the walk state. Do they move? They don't. Yes, they do. Okay, so now, then they pause. Then they resume. Okay, so we can't just do this. Okay, let's wait for them to move, and then we'll open this and see if they fly. Son of a... Why do they do this? Thanks, Squinch. Hey, I appreciate that. Yeah, we post on the Discord there. Anyone who's a game dev or interested in that, you know, we got a little community there where we share different videos or project updates, that sort of stuff over there, as well as ideas and, you know, anything. So, okay, this is really weird. Paused is a global Boolean. Open chest. Paused gets true. Then paused doesn't get false until we advance to the end of the dialog object or dialog box. But we're only updating our scene if we're not paused anyway. So how come they fly away? Okay. I don't know why they fly away. And they speed up for some reason. So let's try to limit our process AI, because maybe I think that's where it's happening, because it's not the update. I think it's in the process AI. We already tried this. Let's just not process AI if we're not paused. And let's just see if that changes anything. I don't imagine it'll change anything because we tried it on the parent block and it's still jacked up. Yeah. I don't get it. Like when we turn off the entity update, we pause. So how come? Yeah, if we turn off the entity update, then we pause once we're paused. We stop updating them. So if we take off the entity update, does our process AI still changes our positioning? So this does pause. That's what we want it to be, but we need to update the entity so that we get the flapping and all of that stuff. So something in the entity update is making us fly all weird. So we've located it down to there. Now it doesn't matter. It's so weird. It doesn't matter if we only update our entities if we're not paused. It's still broken. That's what I don't get. That is so strange. Okay, I am just not making progress fixing this, so we might call it a night. How do we get that to work? Maybe we can flush. See, like I'm thinking of like Band-Aid fixes. Oh, if the movement is based on delta time, pausing the game would speed up the game, making them move faster. I think the movements are based on delta time, but if we're paused, we're just not updating any of the entities based on delta time. We're not updating any of those things. Well, we shouldn't be. And that's, I guess, why I'm confused why this is broken. Because when we're paused, we shouldn't. Let me think. Because yeah, that's what we're doing right here. It's like we're updating the entity based on delta time right here, but we're trying to do this only if we're not paused. Like if we're paused, we don't want to update the entities at all. We just want them to pause. We just want them to stop updating. Let's maybe see. The only thing I could think of is that we're not actually paused. But I doubt that's the case. Yeah, we become paused all right. That is so strange. There must be something. Let me see. Maybe there's one other thing. Now, what doesn't make sense to me is that if we just don't update the entity, then it works as suspected. Even though they move from the AI, they don't update on the entity updates. So that is just really confusing to me. Because if we do this and we can say only process your AI, let's just say was if not paused. This won't fix it because this wasn't even the issue. It was only the entity update that was not working. Okay. Like I just want to get it to not do this. Whether or not that is a good solution is another thing. I've got no clue. I've got no clue why it's doing that. Okay, we'll have to track that down tomorrow. I probably just need a fresh set of eyes on it, but let's check out our get diff here. Okay, we added 2 bats. We added orthogonal distance calculations to go with our diagonal distance calculations. That shouldn't be a line I changed. Distance to player is now set to 10 instead of 28 with those new calculations. And we've got a new credited supporter. Cool. Thanks, Brett Does Twitch and Sasquatch for the subs today. I really appreciate it. We'll call it a day here. I'll commit with a message saying that we Added orthogonal bat to player calculations. And we still have to fix... We have to fix the bat's updating in pause state, which is just... You would think that's a super easy fix. I don't know why it's not, but... hopefully we fix that tomorrow, and then tomorrow we'll get started on the bat attacking state where they spit acid at us. Once they reach this range close enough to us, then they're going to start spitting projectiles at us. So that's what's going to go down tomorrow. Thanks for watching, everyone. I will run the credits here and we'll find someone to go raid. Let's see. We've got Hypnotic Games. Like always. He's working on games stuff, so let's go raid him. He's always doing some cool stuff in Godot. He streams like 12 hours a day. But he's a channel friend, so we'll raid out to him. Have a good night, everyone. Thanks for watching. I'll be back tomorrow. Thanks for hanging out, Squinge. I appreciate it. Thanks, Sasquatch and Brett and whoever else was over here hanging. If you're here still, Loki, thanks for hanging. Catch you tomorrow.